Now you should see on the top of your screen a little note to say recording. And yeah, let's jump straight in basically. So just about myself, my name is Laura. I'm a webtoon marketer here in Seoul in Korea. And as you might have guessed, I'm more of a tech adjacent rather than a tech person. And this meetup was born out of a personal interest. So how can I find and extract meaning from messenger chats using natural language processing? It's a personal interest of mine. And then also I saw a sample project on Codecademy that had a few prompts, which I followed. They're kind of open-ended questions. And that's how this meetup came about, basically. Now, to give you a preview. So what we will start out with is pre-processing. So we will normally...
What is webtoon? What is webtoon?
Webtoons are comics that you can read online.
Okay.
So kind of like if you imagine, it's like Netflix, but for comics.
Okay.
Yeah, kind of like on-demand comics. So for pre-processing, so we will start by normalizing first, which means to put everything in the same case. In my case, I put everything lowercase. And after that, we will be dipping our toes in noise removal using regular expressions. And so for example, things that you don't really need, such as filler words or, for example, punctuation, that kind of thing. We will tokenize. So that means you kind of chop your text into little bits. You chop them into individual words. We will remove some words that are not really conducive to meaning. We will lemmatize. Lemmatize means you bring your word back to its root form. I will show you what that means in particular. And then we will also briefly look into POS tagging. POS means part of speech. So you categorize your language, your words by its functions. For example, is it a noun? Is it an adjective? Is it a verb? To be quite honest, for my purposes, I will skip over analysis with POS because it doesn't really do anything for me. It doesn't really convey meaning. But I thought I'd just include it so that you can have a look how it's done for your own purposes. And then at the end of pre-processing, you should have a string that looks like that. So you have this one string where noise has been removed, and you have a string of strings, basically. But you still have emojis included. And also just to let you know, so I'm using my own data here, my own personal chat. However, I have changed all identifying markers. So I've changed the names of the person, I've changed locations, whatever. So even if the person who I had these conversations with, even if they were watching, they wouldn't know, other people wouldn't be able to tell. It's just to keep that anonymity as well. Now, afterwards, there will be sentiments. So for that, I've used some pipelines and I've used them to classify sentiments. And there's also a model called the Dilbert model, which is a pre-trained model for natural language processing purposes. And at the end of that, hopefully, ideally, you will have something that looks like this, where it tells you the count of neutral, positive, and negative emotions. And I also looked at emotions in a sort of more nuanced way. And there is a pipeline which has 6 different emotions, and the ones that occurred in my case were anger and joy, which were the most frequent occurring one. I will talk about why that is in a second. I'm not an angry person. There's a reason for that. There is also fear, there is sadness, there's love, and there is surprise. And then moving on to topic modeling. So we will vectorize our pre-processed list of words. We will train and use a model, which is called the Latent Dirichlet Allocation. It's kind of like a machine learning model. And then at the end, I found a really cool library, which is called, so again, it's related to this LDA model. So Python LDA visualization to visualize that result of the topic modeling. And then what we come away with at the end is we have different topics and they are grouped by words. Some of them may overlap, and it tells you the most frequently occurring words per topic. Now, yeah, so that's the preview, to be honest. And I just wanted to check with you. Sorry for those of you who are attending this meetup. So again, thanks for joining. And is there anybody who actually wishes to code along live? Or is everybody just here to sort of watch, to have, to get an impression of what you're doing? Because that will dictate on how I will proceed. Shall I give you time to run your commands, or shall I more explain what these different commands do? Okay, so let me just quickly check the chat as well. We have a few more people joining. We've got Jaden. Oh, Chico, you're back. We've got Christian. And Theodore says you would like to code along live. So you've got your library ready, you've got your text ready, is that right? You've got your code editor. Okay. Yasa says, I plan to watch and understand. Yeah. Okay, sounds good. I mean, if you guys want, after the meetup, I could send out a copy of the Jupyter Notebook so you can sort of try it yourself. Would that help? It might be a lot to just take it in just visually. That would be appreciated. Yeah. Okay, sounds good. So in that case, I'm just going to go through my notebook, and I'm going to explain what happens. Okay, let me just bring that up for a second. Just a moment, please. Okay. Now, so I've got my notebook here, and I trust that you can see that quite well. Can I just ask, would you like me to increase, or would you like me to decrease the font size a little bit? Do you want me to leave it as is?
For me, it's okay.
It's okay. Just wait for a few more people to let me know if that's okay. You're starting a code space from the rep. Okay. Is it okay to see that, like, the font size, is it big enough? Looks okay. Yeah. In that case, I'm just going to proceed, and if there are any objections, try to put a little note in the chat, and I'll try and have a look at it. Okay. So, some of the open-ended prompts, I took them and I sort of shortened them for Codecademy. And basically, step one is to just import and look over your data set, open your file, export the content, take a look at the file. How is the information organized? And we can do that right now. So I've got my part here. And if you have a look here, you can already see at first glance, right? There's a lot of information where you probably know that you're not going to need it. So for example, there's a lot of numbers here, right? And then here, every time you send an image, it has these little brackets here, right? And it says image omitted. So you can already think, or here, for example, video omitted. So that is WhatsApp's way of telling you that you have exported your chat, but obviously because you can't really export a video into text, they're omitting that. So yeah, let's have a look. So in our case, we don't really have a data set. It's not a CSV file, but it's a text file. And you actually can read that in like a data frame. But in our case, because we're doing language processing, most of them, or at least those ones that I'm using for this meetup, they require string input or vector input. So in my case, it didn't really make sense to read it in as a data frame. I kept it as a string. Now, step two from Codecademy, it says that now that your data is imported, you can plan what you would like to analyze for your project and what insights would you like to learn and share. And to be honest, my goals were quite straightforward. So I really want to see is sentiment analysis, does it actually really get the sentiments that I want to express? And I, on purpose, I picked somebody who I have very casual conversations with, as well as very, very deep ones. And I wanted to find out, can Python detect this? Can it maybe help explain? Is there anything that I can glean from this? And then I also want to check, is there maybe a change in sentiments? Is there maybe a change in topics? And so my friend and I, we also had sort of different changes in friendship over time. Would that be possible? Now, as for the chat text data, so the media, so photo or video omitted, these are all placeholder values for media files sent in WhatsApp. So again, let's have a little look here. So all these things he omitted, that means they're just placeholders. And we do take them out, actually. Now, so for the libraries, if you have had a look at the boilerplate code, you might have noticed that they're quite a lot, but we don't actually use all of them. That's more for you to have a sort of boilerplate when you do natural language processing yourself in the future. It just seems like a lot. Okay? We will use many of them, but not all of them. Something that I also ran into, so I have used natural language processing in the past. And then what happened was I got a lot of really, really random errors. And then what I found was if I just upgraded my libraries, so pip install upgrade, and then the name of all these libraries, then what happened was all these errors just went away. So that was very gratifying to use. And then also I looked up some other ways to troubleshoot library errors. And then what I found was I'm using, I think, what is the most recent Python version, which is Python 3.11, or at least it's one of the more recent ones. And apparently a lot of the natural language processing libraries don't really work with more recent environments, or they fall. So another thing that you can do is you can try downgrading your Python environment, or you could create a virtual environment with a downgraded version. So these are all options that you have. Okay, just to have a quick look. So we've got our libraries here. Nothing really crazy. We've got matplotlib, pandas, numpy, transformers, then some random ones. We've got a pipeline, we've got textblob, we've got spacey. Then we have an LTK libraries, which I gather is the most commonly used, or one of the most commonly used natural processing libraries. I've got a Lemmatizer here. Yeah, something about sentiments. And then there's also something called GenSim, which again is a library for natural language models. We've got a couple of them here. That's also where our model comes from. And that's also where the visualization library comes from. And then here we've got scikit, which again is a very commonly used library consortium. And then we also need to require a couple of instances. Excuse me. We've got a couple of instances. We've got a Lemmatizer, we've got our stop words, and we have a vectorizer. Now, if we want to go ahead and actually read in our data, so when you go to WhatsApp, you select your chat, you say export chat, and then you save it as a text file, and then you can basically define your path and your file name, and you join that as a path, and boom, you can basically read in your data. And let me just, I can't remember now, did I include that in the boilerplate code or not? If not, I'll just put it in the chat. Okay, like so. And then obviously as a text file, Python or the Jupyter Notebook can't really do anything with it, right? So what you can do is you can read it in as a text string. And basically your text data down here, that is your string that you can then use to pre-process and do with as you please. So that's the reading and data part done. And I'm just going to give Theodore a moment. Theodore, do you need a second? Do you need some more time? You're okay. Okay, sounds good. All right, now we get to pre-processing. So we want to clean the data, we want to prepare it for analysis, and then Codecademy advises that the goal of text pre-processing is to reduce the data and distill it for the parts that will give you insights. And some techniques we recommend for this dataset include tokenization, noise removal, punctuation, digits, symbols, stop words, HTML tags, URLs, text normalization, stemming, lemmatization, lowercasing. Okay, all right. So if we want to normalize our text, we take our text data that we just read in up above and we normalize it. And in my case, you can probably also put it uppercase, but in my case, I just transform it into lowercase text, like so. And then there are some things that I already know that I'm not going. Shush now. I know that I'm not going to be using them. So, for example, I am removing my own name. I am removing my friend's name. My friend's nickname is June. And then, if you recall, in the chat text data, there are these things like image, omitted, video, these little bits up here. So I know they're not going to add any meaning, so I'm removing them as well. And then there are some words where I think also they're kind of meaningless, like hey, I'm, something, thing, WhatsApp. I find that these are not going to add anything. So then I make a little pattern, and it's okay. Let me have a look. I wrote myself some explanations because I found it confusing as well. Let me just put it in the chat, and then we will look at it like so. Okay, so this R means that text is to follow, basically, literal text. And then, okay, so B is the word boundary to ensure matching whole words. Okay, so only we are having words, the words to remove, and what we want to do is we want to have all the text except those words. That's basically what that means. And we also want to exclude numbers. And what we do is we replace all the words that we had in that string, and we replace them with an empty string up here. Okay. So we have our normalized text, and we want to take out our pattern, and we want to replace those with an empty string. And then at the end, we remove the white space, the extra space. That's what that does. Okay. And let's maybe, just to kind of have a little node, we can have a look maybe what not needed like at this point, just to give you an idea what the result is. Wing. Let's have a look, and let's run that. Let's see what happens. Okay. So at this point, we have punctuation, and we have our text, but already you can see that quite a few words have been removed. And the reason why I'm not removing punctuation, I will explain that in a minute, but there's a purpose, there's a reason for that. Okay. Now, so we've got that. And then also I want to make sure that I take everything else out that I'm not really interested. So I do want to keep emojis. That's what all these little things that you can see here. And I do want to keep my full stops. I want to keep my exclamation marks. I want to keep my question marks, but and my emojis. But everything else I want to take out. Okay, and let me just put that in the chat as well. And we can have a little look what that looks like now, how they look different from one another. Okay. Oh, okay. So now we've got a text here. So as you can see, if we compare them a little bit, okay. So up here we still have these kind of marks, some things that we don't really need. Okay. But down here, we make sure that we have our emojis and we have the most important punctuation marks that I want. I think there's probably a better way of doing it. I feel like there's probably a way to sort of combine these, but again, I'm not a tech person. I'm a tech adjacent person, so I kind of have to do it in different little steps. Otherwise, it gets a little bit too overwhelming for me. Now, next thing we do is we tokenize, and tokenizing means that you take your string and you turn them into individual string bits. Okay, let me just put that in the chat. And we can also have a look what that looks like. Okay, so now we have turned into a string that contains, sorry, a list of strings, sorry. And next, what we do is we remove stop words. Stop words can be kind of I want to say meaningless words such as this or the. They don't really add to our meaning of the text. Okay, so if we have a little look what these stop words include, maybe print the stop words just to have a look. Maybe we. Okay, so should, now, didn't, there, had, at. So these are also prepositions, little filler words that are not really needed. Okay. So what we do is we have our text now with no stop words. Let me just put that in the chat as well, like so. Okay. And so basically what we're saying is here, we only want to keep the words if they are not in stop words. So everything that is in stop words gets dropped, basically. And next up is lemmatization. And lemmatization is a little bit interesting because in natural language processing, you generally have two options. And I also had to look up how they're different. So we have stemming and we have lemmatization. And stemming is a bit brutal. It really chops words to their very root form. And what that does, it's faster, but it's less accurate. So, for example, if you have really big corpus of data and you really want to go through them quickly, maybe stemming might be useful. But then if you have sort of less text and you have maybe the resources and the time and the computing power, you might want to do lemmatization, because what it does is it converts the words to their meaningful base form. And that is called a lemma in language studies. And again, for me personally, stemming is not really useful. It's too blunt. It doesn't really leave enough meaning. So what I did was lemmatization. So again, let me just put that up here. So what we do is here we have a lemmatizer instance, right? Let me just show that to you again at the library. So here we have an instance of a lemmatizer. And what we do is we say that we want to lemmatize each word in this list that we've just created. And then if we have a little look here, it sort of reduces words without taking away the meaning. Okay, so for example, speaks or she is speaking gets changed into speaking. Okay, that kind of thing. Now, and just to go over stemming and lemmatization, I found that quite interesting. So stemming is a process that stems or removes the last few characters. So, for example, caring becomes car. So that is quite different, right? So I find it's not really useful for my purposes. But then, for example, if you lemmatize the word caring, it gets changed into the word care. So that is a little bit more meaningful for our purposes. Now, so the next thing, at some point I considered having POS tagging and to maybe analyze any grammatical patterns, but then I found it didn't really interest me that much, to be honest. But just for you, if maybe that's something that you might be interested in, I wanted to show you POS tagging as well. So basically what you do is you make an empty list and then you POS tag all your lemmatized text data, and then you append it to that list. That's it basically. And then if you have a little look here, if you check your text, what it does is it gives each of your text data, it gives a little label. For example, NN means noun, okay, or call also can be a noun. That's how it works. Okay. All right. Now, as for analysis, so again, that is from Codecademy. And what they now advise is that having planned which analyses you wish to conduct on your data, you will now use the NLP skills gained throughout the course and elsewhere to analyze the data to gain the insights of your choosing. Now that you have made preparation for your analysis, it's time to conduct it, okay? And remember, there can be multiple paths to achieving a goal. Yeah, and I have to say that is, shush now. That is also one of my favorite things, where I sometimes will look at different ways of doing something. You still get the same result, but you can do it in different ways. That's one of my favorite things about maybe looking into coding. Okay. And then they recommend some libraries. They have here Spacey and LTK, Pandas. They have TensorFlow, Scikit-learn, Genshin, and TextBlob. And if you might remember, we had these all at the beginning. Okay. Now, what I wanted to see at this point was I wanted to maybe look into emojis. And I want to see, is there maybe some kind of pattern that I can see just to move away from text for a moment? So here is an emoji pattern. I'll put it in the chat, like so. Excuse me. And so what it does is it has different classes of emojis. So for example, faces and I think flags, and I think one of them is more like objects. Okay? So these are all emoji patterns. And then you take out just the emojis and you leave everything else out, basically. And then you use the counter library to actually count them, like so. And I'll put that in the chat as well, like so. Theodore, am I moving through this too fast? Do you need a moment? Does anybody else need a second, actually? Is there anything you'd like me to?
Can we have the access after this meeting to these files to practice our own time?
Do you know what I'll do is I do realize kind of a lot of content, right? It's quite meaty. What I'll do is I'll put it on my GitHub and then I'll share it with everybody who RSVP'd to this meetup. And then you
Okay.
can have a look at it. Is that okay?
Yes, that sounds good.
Oh, okay.
Yes.
Sounds good. I will definitely do that. Now, so we count our emojis and we sort them, like so. Just put them here as well. Yeah. And then we have these labels and we have our counts and we bring them together by zipping them, like so. And then I have to say I ran into some problems at this point. So I wanted to show you the count of the emojis. I'll show you what happened, and I haven't been able to fully fix it. Okay. So what happens is I tried different fonts as well. What happens is some of the emojis do not get displayed. So if you have a look down here, they cannot be rendered. Okay. To be quite honest, I wasn't super fast at this point, because when I looked at the emoji analysis, I realized that the heart and was that like a little kissy emoji and a little crying emoji, these were the most common ones. And yeah, to be honest, that was kind of all I needed. But I have to concede, if you maybe have emojis that cannot be displayed, this might be a little bit difficult for you. But still, nonetheless, maybe that's for you to do at home, like your own challenge, is to have a look and see if you can fix it. Because I have to say, I wasn't able to. I looked around the documentation. I wasn't fully able to fix it. So if we have a look at this error message, says here that these ones are missing from the current font. And again, I tried different fonts. It didn't work for me. Maybe you can make it work. Shoot me a message if you can. I failed. Now, the next thing I did was I wanted to maybe see if there is a way for me to have a look at the most common words and maybe already see any special patterns. And I have to say, I didn't really see anything. These are just very sort of neutral words. It doesn't really tell me anything. So I decided to I'm just going to skip that bit. And I'm going to go straight to sentiments and into topic modeling. And again, what I found is, as I told you in the beginning, some of these natural language processing libraries are not really up to date. And so it sometimes brings up these little errors like, okay, it'll be deprecated and might run out soon. Yeah, and just put that in the chat as well. So the first thing I did was I checked if I can find positive or negative sentiments. Let's have a look. And then I counted them as well. And then what I found was that there were more positive than negative sentiments, which I guess that's okay, because I'm talking about my friend here. That's a good thing. Like so. And the next thing I did is I wanted to have a more nuanced count. So then I went into negative, positive, neutral. Let me put that in the chat as well. And just put that here, like so. And then we can visualize all of that. Okay, let me just send you the little graph over here. So again, very, very simple with matplotlib, nothing fancy at all. And if we call that function, like so, what it does is it gives us it gives us a little count. And then if we have a look here, so most of the words are actually neutral, overwhelmingly. And then we've got half of those neutral emotions. We've got positive emotions, a couple of negative emotions, which I guess it makes sense. When you're friends with somebody, you might not talk about happy things all of the time. Next up, what I wanted to find out, are there more nuanced emotions maybe? And for that one, I used a pipeline. And I think there are better ways of doing it, more nuanced ones. But again, I'm tech adjacent, I'm not a tech person. What I found is simple enough for my purposes is this Dilbert pipeline. And I counted the emotions with that pipeline. Okay. I counted each emotion, and each emotion was labeled. And if it has different scores, then they get appended, basically. Okay, they get counted and appended. Let me just put that here. Wait. And then at the end, what you come up with is, so what I did is I sorted these emotions, and then I zipped them, and then again just a quick little matplotlib visualization, and we end up with, let me show you. We end up with this figure where we have anger, joy, fear, sadness, love, and surprise. And then I was a bit surprised at the beginning because, again, that's a friend of mine, right? Why would there be so much anger? I had a little think. And I think what it is, that friend and I, we both like metal music a lot. And metal music, you might imagine, is a bit more on the angry side, maybe has different sort of more doom and gloom themes. I'm thinking that's where it probably comes from. I find it quite interesting how strongly anger features. Now, okay. And then the next thing I did is I wanted to do more around topic modeling. And so I read a little bit around, and I found that there is a popular library for topic modeling called LDA, Latent Dirichlet Allocation. And I had a look at the documentation on the scikit website. And then what I first found, I tried to read in my data and it didn't work. And I was like, oh God, what's happening? And it doesn't want a list like we did in our pre-processing. It wants an array. An array is basically a list that contains sublists. And now this is the reason why I kept punctuation in the beginning, where I kept in the full stops and the exclamation marks and the question marks, because I use them to separate my pre-processed list of words. And shush now. And I used it to make an array out of it. Okay, let me show you. Okay. And then now if we have a look at our, this is what it looks like. So it's all contained in one big list. And then each one of them contains a sublist, which is sentence. So if we have a look here. Yeah. Yeah, that's it basically. So one sentence is one list within the list. Okay. Then the next thing is you take your array and you read it into corpora, next slide, which is part of that LDA model. And then what you can do is you filter out extreme values. So for example, if they occur really crazy amounts of time, or if they occur very, very few times. It's not a must, but it's something that you can do to try and improve the accuracy. And then the next thing is you create a bag of words representation of your sentences. So you kind of take all the words and put them all together. And then, so this is straight from the documentation, okay? So you take your number of topics, okay? How many topics do you want to get? It's completely up to you. In my case, I just picked 5, but maybe you can take 3, maybe you can take 10. And then the process is how often is the corpus going to be used during training, during the training of your model. And I use the default number, which is 20, but you can probably do more, you can do less, depending on what you prefer. Or maybe if you want to play around and see what different results you get, that's fine too. And then you got your model down here. So you create an instance. So the corpus is your corpus from up there. You use your filtered dictionary of words. The number of topics is the number of topics up here. Passes, and random state 42. So 42 refers to, I think, like a truly random sum. Is kind of, again, it's kind of like a default setting. Let me put that in the chat. Like so. Then we do that. And what I wanted to see just a sort of printed representation. So I wanted to have the top 10 words for each topic. And if we have a look here, we can actually see them. Okay, there's there's Joe, there's C, there's good, Korean, and it's basically about me living in Korea, talking about my husband, going to language school. We're talking about his family. So here you have, for example, kid, baby, all these things. Yeah. But again, I found that a little bit too clunky. I found it a little bit difficult on the eyes, and I want something that's a bit easy on the eyes. So I had a look, and there is a visualization library for Python called PyLDA Viz. And there's a little extension for Jupyter Notebooks. So you enable the notebook, and you take your model, your corpus, your dictionary, and you sort your topics as well. And this here, what it does is it uses your browser, your default browser, and it opens that visualization. Okay, and let's have a look. So if you run all your commands, your default browser will come up and it'll bring up this file here. And I just found it really, really interesting. You can play with it as well. So you have different topics. If you kind of hover over them, it has the most common bits per topic. And some of these topics also, as you can see, they overlap. What I have to say, what I kind of expected was a little bit more where it sort of summarizes. So for example, if I have this topic here, Joe, Korean, I would have thought maybe kind of like life in Korea. Okay, some kind of like mini summary. I think that would be something maybe to work on, if there is a way. And then here we have this bit where we talk a lot about music, right? So yeah, as you can see here, we've got Spotify, we've got metal, great, really. You know, we kind of discuss our favorite kind of music. This one again is about more like life situation, a family, and again that is maybe more about my friend's family, where we talk about how he's doing with his family. Is he doing better? That kind of thing. So I would have maybe liked to have mini summaries per topic. You can also play around with the metrics to sort of make them more or less accurate. And then, as you can see, kind of you can really play with these sliders as well. But yeah, so that's basically it for the meetup. Let me just stop the recording, and then we can have a little Q&A as well. Just one second, please. And stopping recording in 3, 2, 1.